Hello, my dear students and friends. Today in this video, I am going to explain about electrochemical series and its application. Electrochemical series is the increasing or decreasing order of the values of standard reduction electrode potentials for different electrodes. It is the increasing or decreasing order of the values of standard reduction electrode potential. This is represented as ER, not just I'm writing ER not of different electrodes. So reduction is gain of electrode. So let me write the reduction reactions. First of all, this lithium plus aqueous gains one electron to form lithium solid. So this is reduction reaction, and reduction electrode potential for this electrode or this lithium electrode is ER naught value is minus 3.04 volt, and zinc electrode, this is the reaction representing zinc electrode. Zinc 2 plus aqueous gains 2 mole of electrons to form zinc solid, and the reduction electrode potential value standard for zinc electrode is minus 0.76 volt. And there are many electrode potential values between these two. Okay, दूसरा मेटल्स, बहुत सारे मेटल्स है जो लिथियम एंड जिंक के बीच में है. नाउ between after this zinc 2 plus, let me write hydrogen electrode. This is hydrogen electrode. Hydrogen plus aqueous gain one electron to form H gaseous atom, but hydrogen exists in molecular state, so I must write H2, and to balance this reaction I can write 2 here and 2 here, or I can balance this reaction by putting half over here also. Now reduction electrode potential standard for hydrogen electrode is taken to be 0 volt. Okay. Now again between these two electrodes there are many electrodes. Now after this hydrogen electrode, let me write copper electrode reaction. Copper 2 plus aqueous gains 2 electron to form copper solid, and reduction electrode potential value of copper electrode is plus 0.34 volt, right? And lastly, let me write the electrode reaction of fluorine electrode. F gas fluorine atom gains 1 electron to form fluorine atom in the gaseous state. Again, fluorine exists in molecular state, so let me write F2 here and 2 here and 2 here. This is fluorine. Oh, I'm sorry, this reaction is wrong. This is fluorine atom, so I must write 2 over here, and after gaining 1 electron by fluorine atom, this fluorine atom must be converted into F minus. So here 2 must be written, not here. Okay, this is the reaction for fluorine electrode, and reduction electrode potential for fluorine electrode is plus 2.87 volt. Now between any two electrode reaction there are many other electrode reactions which I just not write. Okay, so negative value of ER naught indicates non-spontaneous, which does not occur on its own. non-spontaneous, and positive value of Er naught indicates spontaneous. Means copper 2 plus ion is happy to accept electron to form copper solid, while zinc 2 plus ion is not happy to gain two electrons to form zinc solid. Instead, if I write this reaction, if I reverse this reaction like this, zinc solid gives two electrons out to form zinc 2 plus ion, then this negative must will be positive, and positive value of electron potential indicates spontaneous. So zinc solid would like to give out electrons, while copper solid does not want to give out its electron. So gaining electron is spontaneous, while giving out electron is not spontaneous in case of copper, while in case of zinc, giving out electron will be spontaneous. The reverse is positive, while gaining electron is non-spontaneous. Okay. So these are the substances. These are the substances which gain electron. So these are the substances in which reduction takes place. So these are our oxidizing agents. These are oxidizing agents. Okay. And after reversing the reaction, this will be the substance in which oxidation will take place. So these are our reducing. This will be our reducing agents. So in the application of electrochemical series, we can uh, compare the strength of two oxidizing agents and the strength of two reducing agents. Okay, please note it down. Okay, my dear students and friends, let me come to the next topic, applications of electrochemical series. Okay, so in the applications of electrochemical series, the first application is comparison of strengths of oxidizing agents and reducing agents. So I have already told you these will be the oxidizing agents which gain electron, and these will be the reducing agents which will give out or lose electrons after reversing the reaction. But in the question in the exam, conventionally, reduction electrode potentials will be given. So we need to compare the strength of oxidizing agents and reducing agents with the values of reduction electrode potential. Okay. The first one is, now let us compare these two oxidizing agents which are very common. Zinc 2 plus ion gains electrons to form zinc solid, in which the reduction electrode potential value is negative, which is non-spontaneous, while copper 2 plus ion readily gains these two electrons to form copper solid, and the electrode potential is positive, which is spontaneous. So which substance between these two readily accepts the electron will be our stronger oxidizing agent. So in terms of value of Er naught, larger is the value of Er naught, standard reduction electrode potential, stronger the oxidizing agent will be. Lesser is the value of Er naught, weaker the oxidizing agent will be. So I can write Er naught value is directly proportional to strength of oxidizing agent. Sure. Now, let me compare the strength of reducing agents. Suppose these two are reducing agents. After reversing the reaction, if I reverse this reaction like this value will be positive. Both are positive value. Both are positive values means both processes will be spontaneous. But which one is more spontaneous? The one having higher value of Er naught. So sorry, the value will be E or naught. In that case, E or naught. Okay. In that case, E or naught, oxidation electrode potential. oxidation electrode. If I reverse the reaction will be oxidation, not reduction half reaction. Okay. So in case of oxidation electrode potential, lithium has higher electrode potential than which one? Zinc. So lithium solid has higher tendency to give out electrons. So lithium will be our stronger reducing agent. Okay. So in terms of reduction electrode potential, this will be our reduction electrode potential, and this will be what? Negative. This will also be negative. So in terms of reduction electrode potential, lesser is the value of E naught R, stronger the reducing agent will be. Okay. So reduction electrode potential is inversely proportional to strength of strength of reducing agent, right? So so in this case, let me give the example. In this given examples, in this given electrochemical series, the strongest reducing agent or strongest oxidizing agent will be, or order of strength of oxidizing agent, I can write this will be the, because E R naught value is maximum in case of fluorine, while E R naught value is minimum with negative sign for lithium plus. So lithium plus is the weakest oxidizing agent, while F2 gas is the strongest oxidizing agent. In terms of reducing agent, lithium solid will be the strongest because ER naught value is inversely proportional to strength of reducing agent. So minimum value of reduction electrode potential is for lithium electrode. So this is our strongest reducing agent, while F minus will be our weakest reducing agent. So from the electrochemical series, I can write strongest oxidizing agent, that will be our F2 having highest value of ER naught, and strongest reducing agent will be our lithium solid having minimum value of ER naught. This will be our lithium solid, right? And weakest oxidizing agent will be that having minimum value of ER naught, that is lithium solid, sorry, lithium plus aqueous. This is our weakest oxidizing agent, and weakest reducing agent will be that one having minimum value of reduction electrode potential, maximum value of reduction electrode potential, and this will be our F minus aqueous. Okay, this is the first application of electrochemical series. Please note it down. Okay, the next application of electrochemical series is reactivity order of metals. So less is the value of E naught, more reactive the matter will be will be. That is, I can sum up this statement like this: reactivity of metals will be inversely proportional to ER naught value. Okay. Suppose let me write uh, E naught of A2 plus 2 A solid. So this is reduction. A2 plus, this will be aqueous. A2 plus aqueous will gain 2 electrons to form A solid. A solid is the metal. Okay. And its reduction electrode potential value is suppose minus 0.84 volt, and A naught of B, say 3 plus, will gain 3 electrons to form B solid, and its value is suppose minus say 2.33 volts. Suppose I'm just giving this value, and another metal which is C plus gains one electron to form C solid, and its reduction electrode potential value is plus 0 point some 80 volt, like this. So we can arrange these three metals A, B, C in uh, order of their reactivity. Okay, so using this point, reactivity of metals is inversely proportional to E not R value. So E not R value is minimum for what? B solid. This is minus 2.33 volt. So B solid will be our most reactive metal among these three metals. So reactivity order of these three metals is B solid will be most reactive, and then after B, A will come because this is negative. So A, then comes which one? C solid. C solid will be least reactive. So for this, I can write one reaction here. Now if I say this A solid plus B some Cl3 chloride, this is chloride of B metal, this is aqueous. Now will A be able to displace B or not? This is the question. Here we have already known that B solid is more reactive than A, so A is less reactive than B, so A will not be able to displace B over here. So no reaction will take place, no displacement reaction will take place. A more reactive metal will be able to displace a less reactive metal from its salt solution. Okay, there will be no reaction. But if I say B solid plus A is divalent, okay, ACl2 aqueous, for example, ACl2 aqueous, then this B will easily displace this A from its aqueous solution because B is more reactive than A. B is trivalent, so I must write BCl3 plus A solid. I'm not balancing the reaction, I'm just saying that this reaction will occur and this reaction will not occur. And the third application of electrochemical series is ability to displace hydrogen from acids. Those metals having negative E are not value, okay, will be able to displace or will be able to evolve hydrogen gas, displace hydrogen from an acid to evolve hydrogen gas. And those metals having positive E R naught value will not be able to displace or to evolve hydrogen gas from an acid solution. Okay. Uh, for example, copper 2 plus gains 2 electrons to form 2 copper solid. So E naught R value of copper electron is minus 0 plus 0.34 volt, and E naught of zinc 2 plus gaining 2 electrons to form zinc solid is minus 0.76 volt. So in this case, zinc has a negative ER naught value while copper has a positive ER naught value. So zinc will be able to evolve hydrogen from an acid while copper does not evolve or will not be able to evolve hydrogen gas from the acid solution. This I can write as an example like this. Copper solid reacts with H2SO4 aqueous. This can be 1 molar, 1 normal, whatever concentration is not important here. So copper having a positive value of Er naught will not be able to displace hydrogen to evolve hydrogen gas. So there will be no reaction or no evolution of hydrogen gas. You can say no evolution of hydrogen gas. But zinc solid easily reacts with H2SO4 solution to form zinc sulfate aqueous and hydrogen gas will be evolved. So these are the some applications of electrochemical series. I hope you guys are understand and gain some knowledge from this lecture. If you like this video, please subscribe to the channel and share this video to your friends. Thank you for today.